Okay, so this is a new recording for working with calculators for binomial distributions instead of having to use the formula or those binomial tables. And then they work and they're okay. And honestly, for problems, so this is in chapter 5, excuse me, in the Think Do book, and similar to your WebAssign exercises. And the formula wouldn't be too bad to work for A or for B, because it's just one value. But when you start having to find multiple values, or even the tables may be a little less painful, but the tables only get so many probabilities with it. It's a little limited what you can do with it. The formula is a little more flexible, but again, like you do in something like D, and it's kind of a hassle. You'd have to do, some people, what they get wrong is they'll do it for 2, but then neglect all the other ones. So 2, 4, 6, and 2, 3, 4, 5, all the way up to 8, right? I mean, yes, there's ways around that. So what I'm going to do is I'm going to show you how to use a couple of different calculators that will hopefully help you out here. It certainly takes calculation troubles out of it, and then you can just do the interpretations. Okay, so there's 2. I have these in Canvas. I also have them. This is in modules. I don't have Canvas open, so I can't show you. It's in modules, course resources, online tools, and this is this one I'm going to show you here is a histogram, and this is the other one. So the histogram one's nice because it gives you a graph so you can see what's happening. It's not the most useful one, though. I'm going to show you the other one I think is more useful. So we're looking for the probability of drawing 6 successes out of 10 trials, and there's a probability of success of 0.8. So we got to remember this. You know what I'm going to do? I've done this the second time I've recorded this video, and I haven't. I've had to keep going back and looking. I'm going to stop it and get a pen. Okay, so I wrote those down. Let's go use this histogram applet first. Whoops, what did I just do? Here it is. So for the very first one, we've got 10 trials. Oh, sorry, this is N. Then X is 6. There's 6 successes. And the probability of getting success is 0.8 from trial to trial. And then here we go. So this, see how that's red? That's the probability of getting exactly 6 successes out of 10 when there's a 80% chance of being a success. All right, and so you'll see that if you did this on the tables, or go check that, because this is a starred exercise, you can go look at the answers or select the answers, and you'll see that's exactly what the answer is. Okay, now the next one, what changes is X is 15 and N is 17, same probability. Notice that this is a left skewed distribution too, right? I get these, the probability of getting 0 successes out of 10 when the probability of a success is 0.8 is pretty non-existent, practically 0. And same thing for 1, same thing for 2. I'm starting to see a little thickening at 3. I mean, actually, we could probably figure out what that is. Let's see what 0 says. So 0, yeah, I knew that because it was 0 high. How about 1? Should be the same because it's, and how about 3? 3 said it looked like it's a little thickening. See, there's a little bit of probability, very small. And then, of course, as we get more and more, it's, it adds up. And all the sum, remember, the sum of all of these is 1 because it is a probability distribution. And these are all the different outcomes. And the sum of all those, the probabilities of all those outcomes has to be 1. That's what theory says. Okay, so let's do part B. Says X is 15. Let's see, X is 15, N is 17. Whoops. X is 15, N is, it's going to make me change N first. So N is 17, X is 15, probability is still 0.8, and see that's that bar. And that's one thing I like about this histogram. You can see what probability you're doing. And these are discrete probability distributions too, because there's fixed numbers. They aren't continuous. These are really almost like categories, right? So they're quantitative discrete variables, right? And because of that, we can calculate a mean and a standard deviation. And of course, you have to do a little bit of this here. Do I get a pen going? Yes, I do here. So what I got to do is, if you look at Dr. Stevens' books, he says to find the mean of a probability distribution for a binomial distribution. Well, for a probability distribution, remember, you got to multiply all the probabilities times the value and do a weighted mean. For a binomial distribution, it's a little easier. You just take how many trials divided by the probability of success. So for this problem, it's 17 times 0.8, and this calculator actually does it for us. That's what that would be equal to. And then the standard deviation is the same calculation, except we're going to do Q, or 1 minus P. So for this problem, it's 17 times 0.8 times 1 minus 0.8, which is 0.2. We do that product and take the square root. Remember, this is the square root key, not the x squared key, if you're using the calculator. I say that because some people get confused. And that's what that would be. Okay. So yeah, you use the calculator, I don't care. I mean, the formula is pretty easy too. So that's for the mean and the standard deviation. So now, why am I going to bother to show you a different calculator? Well, this one seems to be a great calculator to use. Well, the next question says they were looking for the probability that we have less than 4 successes out of 15. So 15. Now, the mistake that people will make using this calculator, they'll type in a 4, and of course the probability now is 0.2, not 0.8. So I got to change it to that. And notice how it becomes a right skewed. That's because the probabilities are such. So this says exactly 4. That's a probability of exactly 4. And this is looking for less than 4. So the problem with this calculator, you only see how the only choices are is they're inclusive. They have less than or equal to. Well, that includes the 4. See how it includes, and for this probability, we only want, see how it says less than 4? So we don't want to include the 4. So we can make this calculator work with a 3. In fact, your graphing calculators need the same kind of thinking because they're. So the other calculator I wanted to show you was the stat check calculator. And what's nice about this calculator is it's got all of these options here. It tells me exactly. So that's what this is. When you come back here, you do the equals. So that's the exact one. But then what it does the exclusive one. So like for problem number 3, like this problem here, I don't have to be too picky. I can just go in. I know there's 15 trials, a probability of success is 0.2, and I want to know less than 4. So with the other calculator, I have to get creative with that. With this one, I can just type in, let's see, probability of success is 0.2, number of trials is 15, and I'm going to put in the 4 because I want to know less than 4. Then on this one, you're going to be careful because you got to click calculate. But then look at this. See how this one includes 4. If we went back here to this calculator and I typed in 4, let's see, what was this? 15, and this was 0.2, and I want less than. See how that gives me the 4 bar and all the way down to the 0 bar? This problem doesn't want me to include the 4. So let's look at that probability. Do you see how here, how this is less than or equal to? That's the same probability. This one doesn't include the 4. So it gives us both options without having to think about it. On this calculator, I have to change it to 3. And then you see that doesn't include the 4 bar. It just does 3 to 0 or 0 to 3. And that's how we get that. So you see how this is a nice calculator. You just got to know what you're looking for. You can use this on its test, on a quiz. You don't have to use the table. If it's a show your work question, what I'd ask you to do is grab a picture of this. Now, if you're on a Windows machine, you can grab a snipping tool, use a snipping tool to grab it, and then you can highlight the one you want. So if this were the problem, I would highlight that one, or you can write this out, or you can do whatever. But I want to see the screenshot. You can't just give me the screenshot and not tell me which one it is. Okay, because as you can tell, there's different options. Okay, so and Macs have the same kind of feature. It's just not called a snipping tool. I honestly don't know what. It's been a while since I've used a Mac. Okay, so that's this tool. Let's do this last problem here since I'm doing this. So 2 or more. So we do n's 8, p is 0.4, and we have 2 or more. So come back to that calculator. So 0.4 is the probability. You got to make sure you type the right numbers in the right spaces too. 8 trials, 2, let it calculate it. And 2 or more includes 2. So we're looking at this last one. So that would be the probability of 2 or more. Okay, so that's how you use this calculator. I encourage you to use it. I've got, as I said, I've got these in the Canvas modules, course resources, online tools, and you'll see them. Okay.